Hello.
Left side kinda mute button ఉంటుంది చూడు.
Kindly make the mic off from your end. Hello, am I audible to you all?
Yes, ma'am.
Good morning, everyone. How are you people? Hope you people are all safe.
Yes, ma'am. Good morning.
So today we are supposed to start up with the pending part of the module 2. I hope you people have gone through the PPT and the video which was been shared in the channel. Hello.
Yes, ma'am.
Yeah, so now I'm going to just explain related to that, and also one assignment has been uploaded already in the Google Classroom related to the previous module on product data management. You people just that is a case study. You people just kindly make a report related to the case study in your own words, what you have understood, and upload the same to the Google Classroom by Monday without fail. Okay. So now I'm going to share an PPT in the screen for y'all, which was being already been displayed in the Google Classroom. Right. So in product lifecycle management module 2, we have dealt about different product design process, the methodologies, everything, and some part related to design central development model and how a product ends and related to the recovery of an product, and what are the human factors which are relevant related to designing a product, and finally the modeling and simulation part of the product was left out. So today we will be just focusing related to that. I hope the screen is visible to you all. Kindly respond, any one of you. Hello. So this is a outline which we are going. Yes, yeah, kindly reply when I ask a question. Just unmute and reply. And if you have any questions, you can raise your hand and ask the questions. Okay.
Yes, ma'am.
Yeah. So the outline is just related to the remaining part of the module 2, which will be explaining as the design central development model, what are the strategies involved at the recovery stage, and how when recycling happens in a product. Finally, what are the factors which are associated in product design, human factors, and finally, how the modeling and simulation will be done before manufacturing of a product. So this is associated as a part of module 2, and this completes our module 2 if we deal with this. So first of all, you have to now come for design central development model. So what do you understand by the word design central development model? So it was an central design process approach which was originated in 2003 at Millsway. Okay, in order to create an adaptive content with evidence-based diagnosis, which is shortly called as ACED system. Okay, so this is mainly in need in order to generate an assessment basis model, because there will be many kind of designs which come into picture, and when a design engineer as a team leader has to identify the optimized design, there should be an assessment tool to identify which is more competitive design concept. For that, they should be having a design assessment model. And this model is called to be as design central development model, and this was originated and developed in the year 2003. Okay, so this, let us go for the actual thing what happens here. So you can have a look of central model of an evidence, or a design assessment model also you call. So you have different sectors. As you see, you have a competency, you have evidence sector, you have task, you have presentation, and finally you have an assembly sector also. So by looking into the diagram, what do you understand, at least roughly? Can any one of you just let me know? It should be an interactive session. It is a theoretical subject. Kindly have a look of the slide and let me know at least the first sector. What do you mean by competency related to the design process? Anyone? We have dealt about different design process, how the design process got evaluated, right? And in this market, today's world, there is a lot amount of competency. So a normal regular design cannot make you to the world of competency. So the design engineer will ask for an many number of design process or design sheets for a particular product, and the team leader will identify which design specification details are more competent to today's world. So based on that, they will evaluate and they will just identify at least 2 to 3 design specifications which are compatible. So out of these 3 designs, then they will proceed further for the different sectors. So this all things will be happen in the competency sector, where they do evaluate the designs which are provided by the design engineer. There will be around 10-15 design concepts which will be given for the team leader, and he will identify which is very convenient and competent to the external world. And this design concepts will be then taken to the next sector, which is called as the evidence sector. So what you visualize here in the evidence sector? In the evidence sector, you can see what's happening here. So you have a start model and an evidence rule, right? So the design thing will be here modeled with respect to the specifications given, and it will be evidence rules. Based on the rules, it will be evaluated and checked whether the model done is exactly fitting to the requirement. So the modeling part of the design will be done and its properties will be mapped to show that the given design is economically feasible and it will be okay for the manufacturing part. And this evidence have to be very clear enough. So all the designs which are selected to be compatible will be passed through the evidence sector. So where the model will be designed and it will be checked with respect to the properties of the material what you are using, depending upon which type of part you are going to manufacture, and it will be correlated and mapped. And next comes the task. In the task schedule, what happens is it will be simulated. The model which has been done will be simulated with respect to its features. You will feed which are all the functional properties, physical properties which are in need, and the simulation part will be carried out. So here some task will be done to check whether the product which is being going to manufactured is suitable for the external environment when it is in movement, or if any type of problem arise when the body is actually in movement. Please unmute some people, please. Your voice is disturbing. Please unmute your mic. Please unmute. Okay, so this is the task. So you have to be clear. In the evidence sector, the model will be done and its properties will be mapped, and here the simulation of it will take care. And next will be the presentation sector. So here the model and the simulation part which is being done will be documented, and all the results what they are obtaining will be generated, and a documentation file will be given. So based on the documentation of the manufacturing specification given, the parts will be then manufactured. If needed, a prototype will also be done. So if the prototype works properly, so then the parts will be manufactured. Then the manufactured part will be moved to the assembly sector. So each part here will be manufactured with respect to the tolerance range which has been given already, right? So based on that, you will see that each part will be mated to each other to get an individual product. If any problem in assembling, so then it will be taken care with the competency section and the task. So if any modification have to be made in the design, then it comes back to the first sector where they will change the modification in the design. This won't happen very usually because in the team leader will identify the design which is more convenient and compatible. If sometime in rare cases if it happens, then it comes back to the competency sector. So again with the modifications, it will be tested with the modeling and the simulation, and then again it goes back to the assembly. So this happens until and unless you get an required fit of the assembly for the particular product. So this is about the central development model. So if they ask, you have to draw the sketch and explain also when it was originated. All those things you have to explain. Okay. So this assessment design model will help in identifying what complex of the knowledge, skill or other attributes should be assessed. So what we explained in the diagram, so that is being asked. What behaviors or performance should reveal these construct? What tasks should elect those behaviors? What are the tasks presented? How much evidence must be collected? So in order to assess a model, they should be having some proof. So it depends, the assessment mainly depends upon how much evidence is being collected related to that particular product and how are the tasks of the particular product is being oriented. So every part will be having different tasks. So what tasks have to be evaluated, that has to be presented. And then what task should elect those behaviors. So the behaviors of the design, how it will be with respect to the task which has been given. Who is scribbling on the this one sheet? Kindly remove it. It is for the sake of your people, not to do any time pass over here. So next is what complex of the knowledge, skill or the other attributes should be assessed. So complexity of the design and other skills which are in need will be assessed. So for assessment, where always there should be some rubrics or the concepts on which it has to be evaluated. So these are the list which has to be evaluated for the assessment model. So in the evidence model, it consists of two types. Okay, so one is the statistical model and other one is the this one, scoring model. So depending upon the type of the task which has been assigned, they will be going either with the scoring model or the statistical model. Every model cannot be orientated with the statistical. So it depends upon which product and what task. So based on the task, it will be evaluated either through statistical or through the scoring model. Next is decision making framework. So what are the recovery options for the product? So when the product is in run, so it will be having its own phases, all the 5 phases. So at the end, while recovering of a product, what are the options it consists? So mainly the reuse, the remanufacturing, the recycle and the dispose. So the product which is running have to be very successful. So depending upon the recovery strategies, you will think whether it has to be reused or remanufactured, or it has to be put into the scrap. So you have certain strategies for recovery at the end of a life. Every product will be having an starting and the end point. So it will be having a growth, and it will be having an maturity, and it will be having an decline phase. Along with that, the initiation and the introduction phase also will be there. So at the decline phase, it will be a condition where the product will be going to decline. So it is a stage where the recovery has to happen. So it involves certain strategies. First of all, it should depend upon the condition of the product. So the condition of the product is evaluated based on two conditions. So what is the written volume of the product in its entire life cycle, right? So the written volume, it speaks about the sales and the profit associated with the product. So it could be with respect to the market demand, what is the current demand for the product in the market, what is the actual cost of the product, and what is the MRP of it. So depending upon the cost and the price of the product, the profitability of the product will be evaluated. So this is one line in which it evaluates the profitability of the product. So the other line is that in which it will evaluate the environmental impact on the product condition. So like what are the resources or the materials which are being used in the product, and how it is associated with the environment, whether it is eco-friendly or whether it is affecting the product. All those things will be evaluated. So if the current product is profitable and it is also eco-friendly, then this is best suitable for recovery. If sometimes the product is profitable to a huge extent and it is not eco-friendly, then the product will not be suitable for recovering. Please see that both the condition has to be satisfied. It has to be profitable and it has to be eco-friendly. Then only we suggest that product to go for recovery or recycle or remanufacturing of it, or else it will directly go for being to be an scrap. So this is the strategies which are involved in recovery of a product at the end of the life. If they ask you, you have to explain the diagram with the strategies and also with an example if needed. So you have to relate that to the case studies which will be given at the later stage. Okay, so the recovery option mainly consists of reuse, remanufacture, recycle, or the dispose. So reuse, it depends upon if the product is profitable and it is eco-friendly, and at the decline stage if profitability has reduced slightly, so then it could be recycled to reuse it again with certain modifications so that it helps in improving the profitability again. But if there is a good trend of profitability even at the last stage and it has good eco-friendly concept of the materials in it, then it will be directly feasible for remanufacturing of the same design of the product. And third one is recycle. The profitability has come down and it is very eco-friendly material. They also that material could be used for recycling and use the same material for some other manufacturing of the part related to the design which has been drafted. And last option is to dispose the material, and this happens if it is not eco-friendly, and if even though it is profitable, if it is not eco-friendly, then it won't be advised for remanufacturing, या recycle, या reuse. It has to be disposed. So this is what been explained related to the product condition, what I told you right now. Please clear the screen right away. What the hell you people are doing here? Clear the screen. For what purpose you are here in the Zoom class? Who was that? You come here for seriously studying, not to do time pass, okay? If you're not interested, please leave the room and no attendance also will be given to you all. So this was about the recovery options for the product which has to be either reused, remanufactured, or recycled. So the product conditions what we spoke here in the strategies are being explained here. Okay, so several assumptions have to be made as follows. So one assumption is take back regulations are enforced by the government, and second one is OEMs adhere to the regulations, and third assumption is transportation cost for the product take back is considered as sunk cost across all recovery options. So these are some assumptions which are being made related to the product condition. The condition of the product could be very good or it could be okay or medium enough. And the condition of the product also relates about its profitability and also the material of the product. So based on all these assumptions, it will be evaluated whether it could be recovered or not. So that is explained here. Okay, the condition of the product, it will be evaluated in three basis sectors. One is the cleanliness level, the second is the change of dimension, and the third is wear out life. So how neatly the equipment is being maintained. So depending upon the maintenance of the equipment, you can define the cleanliness level which has been associated to for that particular product. And next is change of dimensions. If the dimensions which are being designed is very feasible and convenient for the workers to work on with that machine, then there is no need for change of dimensions in the next process when it is remanufactured, and that has to be taken care. And the next is wear out life. So what about the wearness associated or related to the material which is being used in manufacturing any part? Okay, so if it is very wearable, then the change of material has to happen in the remanufacturing part. So if the material is not more stable enough, it is not more strong with associated with mechanical properties, then it relates in wear and also corrosion. So you should be very careful in selection of the material so that it has reduced wear and corrosion when associated to the external environment. Okay, so these are also those conditions which are considered to be as in components for evaluation of how good the product is, along with that of profitability and the environmental impact. So this is the same thing which has been explained in the figure 2. The figure 2 is nothing but the components of the product condition which is related to cleanliness, change and the wear out life. Okay, so this was about the recovery of the product based on different strategies. So then you should know about something related to recycling of an product also. So we spoke about reuse, remanufacturing and recycling. So what happens exactly in recycling? So what we do here is, it is a process what we follow in order to use the materials again and again without making it into an waste. So this works out if the material is very feasible, convenient and eco-friendly and not harmful to the human beings and causing any health hazards both for human beings as well as animals. Okay, so this is the concept why the recycling of the material is being done. And it also helps in stopping wasting useful materials, because what happens is it reduces the number of fresh raw materials what we are in need of. It also reduces the amount of energy we use in manufacturing the same material again and again. If it is eco-friendly, it reduce this won't come into picture, and if the material is little bit toxic or harmful, or somewhat in the production of it or in the working operation it is polluting little bit, so it reduces the content of the air pollution if you are not manufacturing the same material again and again. And it also reduces the water pollution as well. Sometimes what happens is the material which is considered to be scrap, they directly dispose to the water, sewage or anything else, so which helps in polluting the water or directly to the river or the lake. So if this has been recycled without disposing it, then it reduces the water pollution also, and also it may reduce the amount of greenhouse effects. So this is very essential concept for recycling of an particular product. So examples of recycling, you know already, if you recycle the paper, it helps in cutting down the trees, right? If you recycle the plastic bags, it helps in overcoming the dangerous hazards which causes due to the emergence of plastics, because plastic degrading will take millions of years and it affects the human beings as well as external environment to the greater extent. And even the food cans which are made from the steel, when you use this food cans of steel for a longer run, it gets damaged, and the same material could be recycled to manufacture a new food can made up of again the steel material, so that it can be reused again. So these are some of the examples for recycling concept of any product. So this was about the recycling. So until now we understood the design assessment model, and then what are the strategies involved in recovery, and what is the concept associated in recycling of an product. And next you should understand what are the human factors associated in an product design. So product design mainly plays a vital role with human beings. You know everyone, we have different stages in the product design where the intervention of the human being is very much needed. And one thing what we have to consider here is any product what we design should be ergonomically designed. If it is ergonomically designed, then only it will be comfortable for the human beings to use. Suppose you can even consider an example of a chair. If the chair is not designed properly, so if you sit on that chair for a longer run, you won't feel like comfortable. You feel like you need to opt for some other chair because you say that this chair is not comfortable to sit for longer time. Why? Because it is not ergonomically designed. So in order to design ergonomically, certain concepts which are relevant to the human being factors also should be included. So this is one of the thing which is related to expert ergonomist evaluation of an particular product. And also there will be various analysis aspects which are associated with the product design. One is the human characteristics which are needed so that it will be comfortable for that particular product. What are the product functions associated, and how the human and the product interface has been taking place. Sometimes what happens, if it is a huge product, it has to be manufactured by part and it will be assembled, and if it has to be done in an environmental area where human being cannot be intervened, then the robo arms will be used in order to manufacture the part as well as assembling. So there won't be intervention of human beings for a maximum extent. Right, so all these concepts have to be taken care whether there will be a proper human interface with the product which will be manufactured or not, depending upon the condition and the criteria. And also human factors will be included in providing the ideas. So idea generation cannot be done by a robot. It has to be done by a human being only, depending upon the survey from the customers or depending upon the ideations or innovative concepts by the designers of a particular company, or through a director or any team leader, whomever could be a member from an organization. So these ideas helps in creating new product ideas, new product functions, and also sometimes the existing designs could be improved by the ideas given by the people of a particular organization. So in idea generation also human factors plays an vital role. So if they ask you what are the human factors associated in a product design, you should be able to explain each and every concept. And next is, it is human factors are also associated in evaluation of a particular product. So how a particular product performance will be evaluated, it will be having its own evaluation strategies. So one could be the measurement of the product characteristics, objects for evaluation and measurement, and customer evaluation. So what do you mean by measurement of product characteristics? So once the product is being designed, manufactured, so it has to be evaluated how the performance of the product is based on its characteristic features. So the measurement of each characteristics of a particular product will be measured. So there will be, sometimes you will be measuring that through some devices, right? But some, in order to measure through the devices or certain softwares in the computer also, there is a need for intervention of the human being. So without the intervention of the human beings, it is not able to be getting the clarified data, right? So it has to be associated with the human intervention to evaluate the measurements of a particular product. And then objects for evaluation and measurements. So this is a basic measurement or the physical features of the product, how the structural characteristics is, how the functional characteristics of the particular product is. Okay, then actually when those these are about the machines which are being manufactured, and then you have to evaluate the performance of that machine. So if you see an example of a speaker here, so you will evaluate the performance depending upon how good it is audible, until where it is being clearly audible, to what range, all those steps. And suppose if you consider any other product, so if you use an for example a good what we say and load cell, right, so you will then evaluate what are its functional performance when it is used as a load cell in different purposes. So how the part which has been manufactured is able to excel in getting the output as per requirement of the customer. So that also will be evaluated. So in order to evaluate the performance or the output of the part or the product what you have manufactured, for that also there is a need for the human intervention. And thirdly, the customer evaluation. You will manufacture the product and you will check all its physical properties, structural properties, and say it is right, done by a human being. And then the output of a product what you have manufactured also will be evaluated based on the result, how it gives, how good it is performing. Suppose if it is a vehicle, how good it is giving a mileage, or it is consuming more petrol and the mileage given is very less. So whatever. So that helps in evaluating the output result of the part what you have manufactured. And thirdly, evaluation of the part or the product manufactured will be done by the customers. So the customers will say that it is 100% or it is okay, yeah, medium, or it is not at all acceptable for us in any way. And this evaluation report also will be given by customers, which are nothing but the human beings again. So each and every sector in which the part or the product will be evaluated in product design is related to the human factors. So this is what you have to explain. If they ask you the human factors associated in product design, you should be able to explain all the 3 slides which was told to you. Okay, so the first one is related to the ergonomic and other characteristics, and then the human factors in a product design. And also, I'm not going to explain you the systematic design process. We have done with the design process already, and ancient design process, ancient design models which was originated also been discussed. And in each and every aspect, even the human being intervention is associated. So that is being correlated here. Okay, that you can have a look later. So it is clearly to say whether it is in regular design, the intervention of human being is needed. In evaluation process, the intervention of human being is needed. And also to check whether it is ergonomically designed or not, the intervention of the human factors are needed. So this you should be able to explain by taking any one or example as a case study. So these are about the human factors associated with the design process. and sub your classification of the human characteristics are given depending upon the systematic design process. Okay, so here it is like visual sensing, auditory sensing, tactile sensing, yeah, attention given, detection, channel processing, yeah, memory concept. So if you're designing a product in which it has to store more memory, what is the capability of the disk what you are using in order to use that as a storage device? Even that has to be defined, configured and programmed as per the requirement. So even that will be done by the intervention of the human beings only. So where it checks the long-term memory or which type of working memory you need, other things. Then processing, channel processing often given parts. So how do you judge the channel processing? How do you identify what is the decision making you take for processing of a channel? Even that is oriented with respect to the intervention of human skills only. And if you want to sense anything of a product, you'll be using different sensors which could be able to do visual sensing, your auditory sensing, your tactile sensing, or in order to provide an attention for the particular product. So all those things are ergonomically variable, and these are all designed by the human ideation to see that whether it is customized properly so that it will be very comfortable for the human beings. Okay, so these all concepts are also being taken care by the intervention of human being, and these are associated as the variables for human characteristics. Apart from that, it is also being explained related to the human factors in performance measurement. So I told you this is before the product which is being manufactured. Before this is at the design level. So after the design level also various performance measurements will be taken care. So it could be the performance measurements vary from one part to other part, or from one product to other product, or it also depends upon the tasks which are being associated to. Right, so I have just given an example for performance measurement. It could be a task assigned where it depends the performance on the time delay, or how the complexity of the design is, or what are the psychological evaluations which are being done. So all these are being listed here. So these are all will be evaluated based on human being performance. These are just the examples what I have given, so related to different tasks. Okay, so this was related to the human intervention in a product design and also in a product. And later you should be knowing about the modeling and simulation part. So why the modeling and simulation is needed? It is very much needed before you manufacture the product into a larger scale, because you have to first check whether the design what you have made is suitable for manufacturing, is it economical, feasible, and can it work properly as per the requirement of the customers, because you cannot waste the material, time and the cost related to manufacturing before you just do a trial. So for trial basis it is essential that you go with modeling and simulation of an product. So here you have to understand what do you mean by modeling and simulation. Okay, so this is about the simulation model. So I can go directly here. Just one thing what you have to understand here is the normal definition for simulation. It continues to be a primary method by which engineers obtain information about analysis of complex stochastic systems such as production assembly lines, flexible manufacturing systems, and reliability systems. Right, there should be some assumptions for the systems what you're going to follow, and you have to do the analysis related to it. So it is very essential that you will take care of all these stochastic systems into a reality world. For that you should be having some modeling techniques which has to be associated. So first you do the modeling and you check the parameters which are needed to generate a mathematical equation and create the modeling part, and further it will be associated with the simulation aspects for different stochastic systems what you will be dealing with. Okay, so this is just a general description related to the modeling and the simulation of an product. So here it describes the modeling elements which are being needed in decision makers environment. Okay, so what happens here is you will be having different stages which will be considered in modeling elements. You should be very careful in identifying the modeling elements which will provide you the proper decision, because these modeling elements are the factors which will show the system to the real world. So the stochastic system what you generate should be almost similar to that of the system what you want to manufacture. If the modeling system is not related to that of the product what you have to manufacture, then it shows that the modeling elements what you have selected is not right. The parameters of the elements selected is not right. So you should be very careful in identifying the elements as it makes an decision making orientation for the particular product. So first step in it is performance measure. The performance measurement of the product will be associated in the step 1. Okay, based on the design, the performance evaluation how it could be will be run in the simulation and that data will be recorded. Okay, so in any performance measurement you will be having an uncontrollable inputs and the controllable inputs. So you have to bifurcate which are the uncontrollable inputs and which are the controllable inputs. So uncontrollable inputs can be predicted and it can be estimated also. Whereas the problem mainly arises due to the uncontrollable inputs and not due to the controllable inputs. So controllable inputs will be controlled and it will be going on systematically. Right, so this will be segregated as uncontrollable inputs which are there in a particular product, and which are controllable inputs will be segregated in the step 4. And then there will be in after uncontrollable inputs, so you have to measure the problem parameters. You have to measure the problems associated with the uncontrollable inputs and you have to estimate how the problem could be overcome. Okay, for that the parameters will be varied. The uncontrollable inputs, if they are having more problems associated to, so then this uncontrollable inputs have to be changed with other input parameters so that the problem associated with this uncontrollable input will be overcome and it will help in developing the system almost nearest to that of the product which has to be manufactured. Okay, so when this problem measurement is being controlled, it goes for controllable inputs. So controllable inputs will be doing in a smooth way, so there will be no problem parameters associated with it. So once step 4 is assigned with controllable inputs, it goes for the interaction. So interaction with the uncontrollable inputs and controllable inputs will help in generating the simulation of the model which is in need. And the simulation of the model will show the functionality of a particular product, how well it is being operated. Okay, so based on the simulation model output data, then the action will be taken. Whether the simulation is acceptable or again any modification has to be made or entire part has to be considered as a scrap. Okay, or else sometimes we do trial and error simulation process until and unless we achieve the required scholastic system which is matching with that of the part which has to be manufactured. So this process has to be taken care properly. So based on what will be the output or the performance measurement, a mathematical equation will be generated. So in that mathematical equation, you will be associating the uncontrollable parameters with certain letters and controllable inputs with certain letters, and you will do the modification of the uncontrollable parameters until you achieve all solving of all the problems, and then the interaction with the input controllable and uncontrollable will be taken care to obtain the required simulation model. So then action will be taken based on the simulation what you achieve. So you should be able to explain this strategy when they ask you how a decision making is done in an modeling system. The same thing has been explained over here. So usually for a simulation of a product, we use an equation here. So it is always acceptable and for an scholastic system performance. So where J of mu will be equal to E suffix y of mu into Z times of y. So that is the equation we use usually for any scholastic system. So here y will be considered as a random vector. So all the random variable vectors will be considered as y, and it is known as probability density function. So f of y comma small v depends upon v, and z is the performance measurement. So here Z will provide you the performance measurement. The performance measurement what we were dealing here will be taken from that value. Performance measurement will be referred by the letter Z. Okay. So this is suppose if you have an reliability system of J of nu, then the equation there are many more simulation equations which are available. The almost established and very common simulation equation is called as Monte Carlo simulation. So this is very feasible for discrete event type of system. So depending upon which type of system you need, that type of Monte Carlo simulation equations you use. Simulation is a vast subject which could be studied in depth. But for you all, you have just a basic information related to simulation and modeling. So if they ask you, you just define what you mean by modeling and simulation, show the simulation model, sketch and explain, and write the basic equation which has been followed for simulation of a particular product in general. And also you can speak about the common simulation equation which has been used by Monte Carlo simulation equations, and explain the term each what is being known. Okay, so similarly the same thing here. V is equal, this is V naught, V is equal to V naught here. So V naught, it represents the law for the larger numbers, and the true values here for y of I is taken as any number right from 1 to n. There is no constraint that you have to restrict the integral value for y. So y will be the random vector, so y suffix I will provide you the integers 1 to n. Okay, so numerical result based on the equation 2 will estimate the value of J of V at V is equal to V naught. So this is just a basic equation, no need of to be much more in depth related to it. Just speak about the simulation, general equation and the Monte Carlo simulation, that is more than enough. So finally, the simulation and modeling parameters helps in improving many factors. One is the performance measure. So performance measure we have already studied here in the simulation model, okay, which is nothing but the parameter Z. And then the uncontrollable inputs also I explained you related to any functional product. There will be controllable and uncontrollable inputs. So the simulation and modeling parameters helps in identifying the uncontrollable inputs, and it also helps in identifying what are the parameters of the business associated in it. Okay, so those business associated parameters will also be able to identify by using this simulation and modeling parameters. Along with that, controllable inputs of a particular part or a product also will be evaluated using this parameters. And then interactions involving these components. So you have different components. So what is the interaction which has been taking place in all these components will be done in the simulation model. So you have shown you the interaction session also, in which all the parameters will be interacted. So that helps in getting interacted with all the parameters. And finally, the action will be taken based on the interaction that is also been explained to you all. And based on the action, you will be able to evaluate what is the scope for the particular product and what are the limitations. Because the action will provide you the limitations and the plus point of a particular product which is yet to be manufactured. So this will help in identifying what is the scope for the product and what are its limitations also. And it also helps in doing reverse engineering. Suppose based on the scope and the limitation, the product has been designed, it has been manufactured, okay, and it has been in the market. So after a certain period of time, some modifications or the suggestions is been asked by the customers. So in that case, redesigning will take a large amount of time. So that is a suitable time where reverse engineering could be done in the existing design. So you can go for reverse engineering with the help of simulation and modeling rather than redesigning using the materials and investing so much. So by using reverse engineering concept through simulation and modeling parameters, you can see whether reverse engineering parameters will be working effectively or not. So if it is working effectively, then you can go for actual reverse engineering of a particular product. So this really helps to identify the feasible problem and to achieve the goal with respect to the requirement. So simulation and modeling plays a vital role in any product which has to be manufactured. It's not associated only related to mechanical products. It could be any products which are being associated to. So these are all the parameters which could be evolved in simulation and modeling. So you have to answer all these and explain if it is being asked along with the concept of simulation, the modeling section diagram, and also the basic equation of the simulation along with that of the Monte Carlo simulation you have to explain. Okay. So that is what being shown here. Performance measurement, I explained you right now, uncontrollable inputs, parameters of the business, action, interactions, controllable inputs, all these are being explained to you already. Right, so this was related to the module 2 with end associated to modeling and simulation. So now you can ask your doubts what you have. You can now speak, you are free to speak with any discussions. Hello? Hope you understood the part which has been. Kindly raise your hands and answer. Hello? I will be giving you the questions based on the module 2 as well as module 1. Okay, the case study 1 you have submitted already. The case study 2 I have assigned you in the Google Classroom. Please submit it by Monday. And one more assignment with the questions related to module 1 and module 2 will be asked and uploaded in the classroom, Google Classroom. You have to upload same in the Google Classroom with the due date which has been given. So now you're free to discuss. Whoa, yeah, please tell me. Hello? Just make your speaker on and speak. Yeah, kindly speak. If you are finding any problem, kindly type the message and let me know. Hello. Hello. Please unmute and speak. Am I audible to you all? Will you answer your attendance?
Yes, ma'am.
From that time I'm asking you, kindly speak. Why you people are not answering? Hope you understood the concepts.
Yes, ma'am.
Yes, ma'am.
Any doubts, you kindly reply. You have to
No
submit.
doubts.
No doubts.
No doubts, ma'am.
Have you understood? And you please cross check the case study. Okay.
Yes, ma'am.
Yes, ma'am.
Yeah, now you have to answer your attendance. Tell your USA numbers one by one.
63, ma'am.
Huh? One by one.
63.
63, okay.
21.
21. 406.
71.
71.
401.
20.
401.
427,
401.
okay. 401 over.
406.
406, okay.
412.
412, okay.
74.
74, okay.
70.
70 over. Next.
0.
6, okay.
11.
11. Please tell one by one. 36.
Ma'am,
Okay.
408.
29.
Okay. 29.
30, ma'am. 30.
30, okay.
01.
Huh?
73, ma'am.
73, okay.
74, ma'am. 403, ma'am.
75.
32.
32. 44. Okay. 55. 403.
Ma'am, 408.
24.
57, ma'am.
57. 408 is
Ma'am,
over.
401. 401.
401. 24.
Ma'am,
Okay.
408.
408. Okay.
44, ma'am.
44.
28. 409.
409. Okay.
74.
74. Okay.
25.
25. Okay.
75, ma'am.
75. Okay.
68.
66.
406. Yes, ma'am.
406.
Ma'am,
Okay.
21. Ma'am, 21. 21.
Over. 21 over.
Ma'am, 01. 4.
0.
10.
36.
404.
404. Okay.
58.
58. 52. Okay.
406.
Huh? Zero six. One by one, please. One by one. Unmute after you answer. Unmute after you answer. 40.
45.
45. Okay.
43.
Huh?
30.
410. Okay.
Ma'am, 28.
28. Shaurya and team, I want to discuss with you all. Stay back. 28. Then
Ma'am, 14, 1, 4.
4 1. Okay.
1, 4.
1 4 over. Over.
01.
0 1 over. 53.
70.
30. 7 0.
04.
0 0 2. Okay. 4. Okay.
75.
75. Okay.
18.
18. Okay.
10.
1 0. Done.
72.
Ma'am, 412.
4 1 2. Okay.
51.
51. Okay.
401.
401. Done.
411, ma'am.
411. Done. 0 4 over.
43.
43. Yes.
68.
32. Yes.
59.
59. 23. Okay.
74.
69.
69.
Okay.
74.
68.
68. After 68. 57.
13.
Okay. 1 3.
74.
Over 74.
13.
72.
13. Over.
72.
Okay. Done.
62.
49.
62. Yes. 49. Yes.
71, ma'am.
71. Done.
43.
48. 43. Done.
Ma'am, 408.
Done. I have written thrice. You are telling me third time.
42.
42. 15 series.
014.
0 1 4. Done. Who else? 0 2 3. Okay.
72, ma'am.
72 over.
051. 51.
Okay. Please mute your audios once you have answered your attendance. That's all right?
51, ma'am.
Huh?
51.
Yeah, over. 51 is over.
No.
Okay. And please submit the assignment on time without fail. Okay, everyone? And Shaurya and team is here related to the project?
Yes, ma'am.
Yeah, Shaurya, what about the progress of your this one project?
We're doing the simulation.
Okay. You got with the problems associated with that MATLAB cleared?
We didn't
There's,
get to meet him only, ma'am. That's why. There was a lockdown now. So we're doing
there's
it
no,
ourselves, ma'am.
No, you get some open course where also the tools and the procedures you could be done, and some case studies and
Yes, ma'am.
examples also how they have done it. So at least if you go
Yes,
through
ma'am.
it, you will be able to clarify the doubts what you have. But you see that you
Okay, ma'am.
complete the simulation without fail. Okay. Are you doing
Okay,
the
ma'am.
fabrication part side by side or it is
Yes,
and
ma'am. You told us to do the simulation first, so we stopped it. Otherwise, we can do it we can do it side by side also, ma'am.
No. Now because first you have to see the
What do we
simulation
do?
result, right? So only I thought, and now
Yes,
it's
ma'am.
not better for you people to go out and do the fabrication part also. So at this time you
Yes, ma'am.
see that perfectly you get cleared with the simulation part.
Yes, ma'am.
Okay.
Okay, ma'am.
Okay then.
Yes, ma'am.
okay,
Yeah, take
okay.
care. Yeah, take care then. Bye bye. You have an afternoon
Okay, ma'am.
session at
Okay,
2:40. Okay.
okay, ma'am. Thank you.
Yeah. Bye bye. And bye for everyone.
Bye.
Be careful and take care of yourself and submit the assignments on time without fail. Don't let
Okay.
me do ask reminders one after the other. Okay.
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 Yeah, yeah.
Okay, ma'am.
Take care. Yeah. Bye bye.
Bye.